Hello, this is our video documenting our program that we made called The Game of Life. This is based on a program made by John Conway, which he also dubbed The Game of Life. So the idea of this program is to simulate human life in a very, very oversimplified way. The way it works is we have this 50 by 50 grid we'll call Earth, and each cell within in the grid is like a person. And all the cells that are black are dead or unpopulated. And a cell that's highlighted yellow is alive. It's a populated living cell. And how the game works is the way we can simulate life is whenever a cell is populated, like that yellow highlighted cell, we count up the neighbors that surround the cell. And the neighbors that surround the cell are these 8 cells right here. And if a cell that's lit up has 1 or no neighbors, it will die by solitude. Very simplified, of course, version of life. And also, if a neighbor has 4 or more lit up neighbors that are also populated, it will die of overpopulation. And the only cells that will live on to the next generation or code that's run would be a cell with 2 or 3 neighbors that are populated as well. And any cell that starts off as dead will only become populated or lit up when exactly 3 of the neighbors around it become alive and populated. It makes a lot more sense just by playing with it. So that's what we're going to do. We can see that this cell that I just double-clicked became populated. I'm also going to click a few more cells so we can see how the process works. Oops. Every time I double-click on one of these cells, it becomes populated. And now to run the program to see who will survive to the next generation, we could increment the process by clicking the step button. So every time I click the step button, we could see that different cells die and different cells become alive, following those basic rules that we established in the code. So you could click the step button to watch it grow and die every generation, or you could click the start button and it will continually do it for you until it reaches a stalemate or until all the cells die. So as we can see, the point of the game is to try to make life go as long as you can. This one's actually going for a while. This is an example of a stalemate right here. These as well, where nothing touches it until they get interaction from other cells around it. You could stop the process at any time by clicking the stop button and clear the contents. A cool feature about this program as well, we saw a little bit over there, is if you start or you approach one of the extremities of our flat Earth here, the program will pop you out on the opposite side. If you go through the top, you'll pop out the bottom, as we can see right here. If you go to the right, you'll pop out the left, and you'll continue to grow everywhere. Like I said, there's also stalemates involved in this. We saw the square, which is a classic one. Another very common one you could reach is just 3 in a row. It'll continually go back and forth like that forever. So it's a neat program to play with, try to figure out how long you could sustain life in its simple forms, and hope you enjoy playing with it yourself and see what you can do. Thanks.